we're day 2 today. And this is number 63 out of the book, I believe. If you don't have your book, that's fine. It's on page 470. I may have wrote down the wrong numbers for the page numbers, because I think the page numbers I wrote down the other day may not have been from this lesson. So I'll have to adjust that today too. If you noticed that, that was my fault. I just noticed that from looking at my sheet here. Okay, number 63. So it's going to look very similar to what we did on Friday. We're going to have multiple inequalities. Okay, this is very similar to the one that we did at the end of the lesson on Friday. We have the x and y greater than or equal to 0. And so when I see x and y greater than or equal to 0, especially when we do our ones tomorrow when we have some story problems, that's telling us that x and y have to be 0 and above. So basically that limits us to the first quadrant of the graph. And so when we do these on a graph, I'm only going to draw the first quadrant in here. You can do the entire coordinate plane if you want, but because we're limited to that quadrant 1 up there, there's really not any reason why we would need to use the entire coordinate plane. So I'm just going to draw the first quadrant up here, make it a little bit bigger. Okay, these two are both in standard form. And you can graph those however you want to, okay? But solving it for y isn't going to be real ideal, because I would have to subtract 5x and divide by 3, and that's going to get a little bit nasty. Okay, so if you want to solve it for y and get it in slope-intercept form, it's doable, but I probably wouldn't do that. And so I would just do what we've always done with standard form and do the cover-up method. And we're going to do it twice. Once for the top equation, and then once for the bottom equation. Okay, so let's start with the first one up here. 5x plus 3y is less than or equal to 34. If I plug 0 in for x, we're going to cover it up. So we have 34 divided by 3. So I'm going to write 34 over 3, which is like 11.3. Either one of those would be okay. But I'll show you why we want to write the fraction in some cases. The fraction is going to be a number that we might need in some cases. If I plug 0 in for y, I'm going to cover this up. And then I have 5x is equal to 34, basically. So I have 34 divided by 5. Which is 6.8. Fraction in the decimal. Bless you. I'm going to go ahead and put those, well, let's go ahead and do our other 2 points first. And I'll show you why I want to do these first. Let's go ahead and do these. These are a little bit cleaner, a little bit nicer. If I plug in 0 for x, 30 divided by 5 is 6. And then if I plug 0 in for y, 30 divided by 3 would be 10. Okay, my two y values are 11.3 and 6. So when I go up on my y-axis, 11.3, I need to make sure I go up at least to 11.3. And then my x-axis, I have 6.8 and 10, so 10's my bigger number. We got to go out to at least 10. And we're going by ones in both cases. And you can label the whole axis if you want to. Okay, then we're going to plot our points onto that coordinate plane. So we have 0 and we have 11.3. So we're going to kind of approximate about. This is why I like the decimal, but I'll show you in a second why the fraction is going to be helpful as well. But 11.3 would be just a little bit above 11 on the y-axis. 6.8 is going to be right here. We're going to connect those together. I'm going to label both of those so we know what those numbers are representing. Then we're going to go 0, 6. And we're going to go 10, 0. Okay, and then what we talked about on Friday is we got to shade this, right? It's an inequality. We started with inequalities on this. The x and y greater than or equal to 0 tells me it's going to finish in this first quadrant. Both of these are less than, so if I were to plug 0, 0 in, both of these are going to be shaded below. So it's shaded below both lines. So the shaded region that we are looking at here is going to be this area right in here. But this is where it's going to get different than what we did on Friday. Okay, we're going to take it one step further. At the very beginning of the problem, they give us this equation. Okay, and it's an equation. It's not an inequality. And as we look at this, just so I use the same wording that they use. It says to find the maximum and minimum values of the function based on the function that is given to us. So this is a function that we're given. And so we're going to take the 4 points that enclose that region. And it's not always going to be 4. In this case, we have 4 points that bound that in. Okay, it makes like a 4-sided figure. It's not a square, it's not a rectangle, it's just kind of a weird looking 4-sided figure. So that's the 4-sided figure that gets enclosed. I have to find these 4 points that enclose that. Okay, 3 out of the 4 are really pretty easy. The 4th one is the one that's going to be a little bit of work to find. Okay, so the 4 points that we have would be 0, 0. 0, 6 was one of our intercepts, so that was easy. That's why I label them, so that when I look back at the graph, we know where that point's going to be at. Same thing down here. That's why I labeled this one. You could use 6.8. 6.8 is an exact value. It's not a decimal that goes on forever. So you could either use 6.8 or you could use 34/5. If it would happen to have been this number right here, this was a repeating decimal. I rounded it. But if I was going to plug that number back in, I probably would use the 34/3. I wouldn't use 11.3 because it wouldn't give me an exact value in that case. But in this case, 6.8 is an exact value. It doesn't go on past that. So we could do 6.80, or you could use 34/5 if you want to. Fraction or decimal is okay in that case. This point right here is the one that we're going to have a little bit of issue to try to find. Okay? And you don't just want to count or guess, because in some cases this might be a decimal. So I don't just want to go 1, 2, 3, 4, and goes up. And I may not have graphed it very well. Okay? I'm just kind of freehanding it here, so it may not look perfect. But we have to find this point. Where is the intersection of these two lines? So what would we do in order to find the intersection of those two lines? What would be the best way to do that? Think about things that we've done throughout the chapter so far. What do you think, Ryan? You said something, huh? And we did graph it. Is it really easy to tell where they cross at? No. So it's kind of hard to tell off the graph. We did graph it, but if you used a piece of graph paper, maybe you could tell a little bit better, but there's an even easier way than just graph. What'd you say? Okay, but we got to have something to plug back in. Think about all the methods that we have talked about. So the very first section, we did graphing, which we did, but it's not really easy to tell where they cross. Okay, you guys want to do substitution here? Anybody want to do substitution with those two equations? No thanks, right? You want to do elimination? Maybe, okay, but that'd be a lot of work. What was our go-to method to find the intersection of two equations? If we didn't have to be given a certain method to solve with. Matrix, for sure. Okay, so we're going to put this into a matrix. Okay, so my matrix would be a 2 by 3. And so we're going to go 5, 3, 34. And we're going to go 3, 5, 30. So by far and away the quickest and easiest way to solve the system of equations there. And we're looking for the intersection of those two equations. And it should look pretty close to what we have right here, okay, when we graph it. My graph may not be perfect, but it should be pretty close. Okay, what do we get? Anybody type it in? 5, 3. Okay. So this point right here is 5, 3. And that would be my fourth order pair, 5, 3. Okay. That was not too bad, right? Especially for freehanding it. Over 5, up 3. Okay. It's off just a little bit. So, but the reason I tell you that is because don't necessarily go off it. And that's why we don't want to count, right? If I would have counted this, I probably wouldn't have come up with 5, 3. If I would have used a piece of graph paper, I probably could have gotten it a little bit more exact, but you don't necessarily have to do that because we're going to use the matrix probably to solve it anyway. So this is just kind of giving us a ballpark about where it should be. So those are our 4 points that enclose that bounded region. Now we want to figure out which one of those points give us the maximum or minimum of this function. Okay, so we're looking for two values. The minimum, which gives us the highest value, which one gives us the lowest value based on this focus. Sometimes we call it the profit function. Sometimes we call it the maximum minimum function, objective function. There's a lot of different terms or words that we use for it. When we do like a story problem, then what it tells me is what's the most, like if I was doing a money question, what's the most amount of money I could make if I was like selling two different items based on how much I produce and how much I sell. We don't really have any story behind this one. So there is no situation that we're trying to identify. Tomorrow we will do some story problems where we're actually finding what the numbers represent, what they mean. So here's what we're going to do. We're going to plug all 4 of these points into this function. This function does not get graphed. And we know the difference because those are all inequalities and this is an equation. This equation we don't use until the very end once we've identified those 4 points. And it may not always be 4 points. Sometimes it might be 3, could be 5. It's going to change depending on the problem. So when I plug in 0, 0, that's pretty easy. 5 times 0 plus 36 times 0 just gives me 0. Not much work to be done there. Okay, this one would be 5 times 0 plus 36 times 6, which is 216. This would be 5 times 6.8 plus 36 times 0, which gives us 34. And this one, we would go 5 times 5 plus 36 times 3. $108 plus 25, so that would be 133. Okay. This value obviously is my minimum. 0 is the lowest value out of all 4 of those values. The highest is the 216, so that is our maximum. I will tell you that a lot of times this intersection point is going to probably be your maximum, but not always, okay? And the reason why that intersection point, if I was doing a problem where, once again, if it was a production problem, kind of like we talked about last week, where I'm producing 2 different things, then you want to be able to produce some of each. And if the best profit is only selling or producing one of the items, then I probably wouldn't make the other one. So we want it to be some of each. In this case, it's not. So that's why we got to check all 4. Which one maxes it out the highest? Okay, so just takes it a little bit further. This part's the part that's right here. That's a little bit new. You might remember this a little bit from Algebra 2. We call this linear programming, where we have functions that we're going to use to provide an answer based on a given set of solutions that we have. Okay, so linear programming is what we call this. Okay, I'm going to do one more example with you. This one along the same lines, but just a little bit different. This one is number 61. And it's on page 469. Okay, it's going to look very, very similar to the one we just did. Okay, a couple of things that are different. This one only has one standard form equation, and then it has an equation with x's and y's. We kind of talked about that on Friday a little bit, of what that would look like and how that's going to limit our answer a little bit. And then we also have, on the last one it had the letter F. This one has the letter P. P equals 17x minus 3y plus 60. Okay, and remember that one's kind of like set off to the side. This is the one that we're going to use at the very, very end. We're not going to do anything with it until we get those ordered pairs. So we got to do a lot of work before we ever get to this equation. So I kind of put it to the side and deal with that when we get to that point. Okay, we definitely want to get these 2 points, right? We're going to graph this line. Okay, let's talk about these 2 right here. So first of all, this is saying my x values have to be between 0 and 7. This tells me my y values have to be between 0 and 4. Okay, I'm going to start by graphing those 2 first of all. And it's kind of the same idea we talked about here just a second ago. X is between 0 and 7. So on the x-axis, we're going to stay between 0 and 7. So we're going to make a vertical line at x equals 7. My y-axis would be the other boundary for that, between 0 and 7. My y value has to be between 0 and 4. So we're going to go up 4, and that would be a horizontal line. Okay, I'm not really doing any shading until I get to the very end, but right now, with just those 2 inequalities, it's going to be this little rectangle in here, if I were to shade it, okay? And then obviously we're going to throw in that standard form equation in with it and see how that mixes in with the other 2, okay? But I start by doing the vertical and horizontal lines first, if we have them. Once again, we're limited to the first quadrant here. So I'm not going to use the entire coordinate plane. I'm just going to focus on that first quadrant. Okay, on the standard form equation, once again, if you want to solve it for y, you can, especially if you want to put it into the calculator. But I think cover-up method is the way to go on most of these. If I plug in 0 for x, 48 divided by 8 would be 6. If I plug in 0 for y, 48 divided by 6 would be 8. If you wanted to get really perfect here, then you probably would want to use a ruler to try to make it as close as you can. And that one is less than or equal to. So if I put 0, 0 in, it would still be shaded below. So now the shaded region that we're looking at here would be everything that's bounded in this little area right here. Okay, and like I told you before, the number of points that are going to enclose that is going to change based on your lines that you've got here. You've got a bunch of linear equations, but as you look at what we have here, we kind of got this weird looking 5-sided figure. And this side is a really, really short side, but it's not intersecting quite on the x-axis. So there's a little point right here above the x-axis where it's going to intersect. So we got 5 points that are bound in it. We got to identify those 5 points. Sometimes it's 3, 4, 5. It's going to change on every problem. It's not always going to be the same. Okay, once we have it graphed, once we've identified all those points, and then we're going to take those points and we're going to plug it into our function at the end. So now we got to identify those 5 points. The ones that are on the x-axis and the y-axis should be pretty easy because we've already identified what those points are going to be. So this one down here is going to be 1, 2, 3, 4, 5, 6, 7. Okay, it crosses the x-axis as 7. So we have 7, 0. We have 0, 0. We have 0, 4. Okay, and this one is not, you probably don't need to use your calculator for this, okay? We have this line right here, which is my one with the slope to it, my standard form. And then this line right here, what would this line right here be? What would we call this line? Y equals 4, right? This line is the y equals 4 line because it crosses the y-axis at 4. So that means I'm going to plug 4 in for y right here. So we would have 6x. Let me see here. 6x plus 8 times 4 equals 48. I'm not going to worry about the less than or equal to sign. I'm just solving it for x here. So we have 6x plus 32 equals 48. Subtract 32. And we get 16 divided by 6, which is going to be a decimal. Okay, I'm going to go ahead and leave that as a fraction because once again it's a repeating decimal. Okay, it's 8/3. So when I plug that in, my x value is 8/3. My y value is 4. Okay. We plugged 4 in for y because that's my y value, and we got 8/3 for my x value. Okay, everybody good with where those numbers come from? Questions on that? Okay, we got one more point to come up with. We got this guy right down here. Okay, what would this line right here be? X equals 7 line, right? Because it crosses the x-axis as 7. So we're going to do it very similar to what we did up here. We're going to take 7 and we're going to plug it in for x. And we're going to solve for y. And so that gives me y equals 3/4. So we plug in 7 for x, and we get 3/4 for y. Okay. I probably would lean towards doing fractions as opposed to decimals there. 0.75 is fine, but like on this one here, because it's repeating, that's why I would stay away from the decimals. We want to come up with an exact value. Okay, so those are the 5 points that we got to come up with. Okay, we got to identify what those 5 points are going to be. We're going to take those 5 points and we're going to plug them into this p function and figure out which one gives us the max and which one gives us the min. Okay, I'm going to leave off the 3y here because 3 times 0 is 0, so I'm not even going to do that part. I'm just going to do 17 times 7 plus 60. And it doesn't really matter what order you do these 5 in. So how you list them out, you got to find all of them anyway. 0, 0 is going to be 0 plus 0 plus 60, which is just 60. 0, 4, 17 times 0 is 0, so I'm going to leave that part off. So I'm going to do negative 3 times 4 plus 60. Which would be 48. Okay, these two are the ones that are a little bit more work because you got an x and a y. So we're going to go 17 times 8/3 plus, or minus 3 times 4 plus 60. And then same thing here, 17 times 7 minus 3 times 3/4 plus 60. So we're just plugging all 4 of those order pairs into that function. Okay. And this one, you should be able to just plug it right into your calculator just like that. Use parentheses. What do we get here when we plug in 8/3 and 4? Try plugging that one into your calculator. Eight thirds 4. Anybody get that one? It'll be a decimal. Both of these are going to be decimals. Okay, 93.3. Okay, and then for the last one? Okay. Okay, and then we just look at our 4 values here, or 5 values, sorry. The maximum, 179 is just a little bit bigger than 176.75, so 179 is going to be my maximum. And then my minimum is the lowest value, and that should be the 48. Okay, in some cases, just kind of pay attention to how the question asks is, this would be the minimum value, and it happens when at 0, 4, or what is the ordered pair where it reaches its minimum. Same thing here, it reaches its maximum of 179 at the ordered pair 7, 0. So in some cases, it may ask you what ordered pair does it reach its minimum or maximum, and then what is the actual minimum or maximum. Okay, those are our 2 problems. So on that one, we really didn't even need to use our calculator maybe other than just plug those numbers in at the end. There's not really anything to solve for calculator-wise because we don't really need to use the matrix. Sometimes matrix is needed, sometimes may not be. Okay. Assignment today is page 470, and like I said, I'm only going to give you one problem, number 64. Yeah. So you can just add it on to the end of Fridays. Fridays, did I tell you 4:55 and 4:56 on Friday?
Let me see. Yeah.
Okay, it should be, do what? And is that what I gave you guys?
I got 4:55.
Okay, yeah, I wrote it down wrong. Yeah, 468 to 470 is what it should be. You're right. Okay, so make sure, I can't remember what I told you on Friday, but I just looked at my sheet here and I still have 4:55 to 4:56 written down. That's from the old book. So I may have given you the wrong page numbers.
This is so janky.
What's janky?
From this, I understand it all. I was just trying to do it in a different way so I don't have to do so much work.